we are going to review the basic skills you're going to need in the survey course that you likely encountered in your previous chemistry courses. Okay. Those skills are going to be reading a periodic table, drawing Lewis dot symbols for a given element, predicting ionic charges, and understanding the difference between an ionic and a covalent compound. Okay. So when reading a periodic table, recall that all of the rows are referred to as periods. So you have period 1, period 2, and so on. The columns are going to be your groups. So if I'm talking about an element in group 2, period 3, that will be this magnesium here. We also refer to the elements in group 17. We refer to those as halogens. I will be using these terms often in this course. The group 18 elements are going to be noble gases. We are not going to be concerned with the transition metals in this course. That's going to be all of the elements here in this center. We're not going to talk about those. We are concerned with the main group elements. That's going to be all of the elements in groups 1 and 2, and all of the elements in the last 6 groups of your periodic table. You also need to be able to quickly determine when you have an element that's a metal and when you have nonmetals. This is important for determining whether a compound is ionic or covalent. In order to do this, recall that you can draw in that staircase, so locate boron and start right under boron, and then you can draw this staircase like this. What this means is that everything to the left of the staircase is what is classified as a metal. Everything to the right is going to be classified as a nonmetal. Do recall that your hydrogen is also considered a nonmetal, even though it is to the left of that staircase. That is the only exception. Right. We also need to be able to extract information from each cell. Recall that in one cell, so let's take argon here in group 18 as an example. Recall that this number up top is the atomic number. This atomic number informs you as to how many protons argon has. Recall that protons are positively charged. So that 18 tells you that argon has 18 protons. You can also get the molar mass from a cell. So that number down here, which is a bit small to see, but remember that that molar mass there is going to be in units of grams per mole. So for argon, that number there is 39.948 grams per mole. That would be the molar mass of argon. Okay. There are 2 more things that we need to be able to get out of a periodic table. And that is going to be the number of valence electrons that an element has, and then we also need to be able to predict its ionic charges. So recall that in order to determine how many valence electrons a particular element has, you just count the group number that it is in, again ignoring the transition metals. So let's take chlorine as an example. Let's say I want to draw a Lewis dot symbol. This is the same thing as an electron dot symbol. Let's say I want to do that for chlorine, which is located here. The first thing I need to do is determine how many valence electrons it has. So that means I am going to count 1, 2, skip the transitions, 3, 4, 5, 6, 7. It is the 7th column. So because of that, it has 7 valence electrons. So if I want to draw the electron dot symbol for chlorine, I would start by drawing its element symbol. I'm going to do that in blue. I'm going to draw its element symbol. And then I'm going to put in a dot for every single valence electron that it has. So chlorine has 7 valence electrons. So first start drawing your dot on each edge, on each of the 4 edges of chlorine, and then you can start pairing them together. 6 and 7. Okay, so that's a total of 7 dots because chlorine has 7 valence electrons. So this is how you draw the electron dot symbol or the Lewis dot symbol for chlorine. Recall that when they are paired together, we refer to this as lone pairs. So these guys here are going to be referred to as lone pairs. And this one here, which is unpaired, we just refer to that as an unpaired electron. Okay. We also need to be able to predict ionic charges. So here recall that your ionic charges are determined by whether you have a metal or a nonmetal. So if you have metals, metals tend to lose their valence electrons, nonmetals tend to gain them. So the trend for that is in the first group, the first column, we are going to have all of those are going to form 1+ ions. So when one of these elements in group 1 forms an ion, it's going to get a charge of +1. In group 2, it'll be a charge of 2+. Group 3, again, we skip transition metals, so group 3, that's going to be 3+. Now, carbon is not really going to form ionic compounds. We will talk about carbon extensively in this course. It's typically covalent compounds, so we're not going to assign a charge to that. So now let's go on to nitrogen. Nitrogen is going to be negatively charged. So now nitrogen is going to have a 3-, oxygen a 2-, and then all of your halogens are 1-. The reasons for this was extensively covered in a previous chemistry course. Here we're just noting the main points. Okay, so when you look at a periodic table, you need to be able to determine quickly what kind of ions these elements will form when they are part of a covalent compound. So let's take magnesium as an example. So I have magnesium here. If I want to show the ion that it is going to form, if I want to predict that, well, because it's in group 2, I know that it is going to form a 2+ ion when it is part of an ionic compound. I can do the same for chlorine. Since chlorine is in group 17, because of this trend that I highlighted, I know it's going to have a negative charge. So this is how you can predict the ions that your elements will have in an ionic compound. Now let's consider the differences between ionic and covalent compounds. Okay, so recall that for an ionic compound, the key here is that the electrons are transferred between atoms, meaning one atom is going to take that electron completely toward itself. Covalent compounds, however, they share electrons. So what this means is that you're not going to form ions. Instead, the electrons are going to be shared between two atoms. So let's look at ionic compounds first. So in an ionic compound, electrons are going to be transferred from your metal to nonmetals. So the first thing to remember is that ionic compounds happen when you have a metal with a nonmetal. So metal plus nonmetal. Now magnesium is a metal because it's on the left-hand side of your periodic table. Chlorine is a nonmetal. So this is going to form an ionic compound. That means electrons are going to be transferred from magnesium, who's going to want to lose electrons, to chlorine, who's going to want to gain them. And what I'm showing you here is that magnesium is going to give up both of its valence electrons, one to each chlorine, because the most you can have is 8 valence electrons around. That is something that we refer to as the octet rule. Okay, so chlorine has, you're going to need 2 chlorines in order to be able to fit both of the valence electrons of magnesium. So now magnesium is left with a 2+ charge, as we discussed in the previous slide, and each chlorine atom is going to have a negative charge. So now recall that your ionic compounds are net neutral. So these are going to be net neutral compounds. Yes, it's made up of ions, meaning things with charges, but overall it has a neutral charge. What does that mean? It means that magnesium, yes, is going to have a 2+, but then it must pair with 2 chlorines because each chlorine is going to have a negative charge. So you're going to have a total of 2 negative. The magnesium is a total of 2 positives. So +2 minus 2, that's going to give you 0. And this is what we mean by a net neutral charge. So when we write the chemical formula of magnesium chloride, we must write it as magnesium with 2 chlorine atoms because that's what it needed in order to be net neutral. Now let's consider a covalent compound. In covalent compounds, we do not hand one electron or however many completely to another atom. They are actually going to be shared. So here what I'm showing you is that these 2 electrons previously belonging each to 1 chlorine atom are now being equally shared by both. In order to show this, we use a dash to represent the 2 electrons here that are being shared by chlorine. Now the rest of the lone pairs will remain. Those are not given dashes, those are just dots. And this is how we can tell the difference between your lone pairs and what we call the bonding pairs. So bonding pairs in Lewis dot structures, so now we're going from a symbol to a structure, the bonding pairs are shown as dashed lines. But the understanding here is that that dashed line is representing 2 valence electrons. Those 2 valence electrons are involved in the covalent bond. So this is the difference between a transfer of electrons, which is what happens in ionic compounds, versus sharing electrons, which is what happens in covalent compounds. All right, so given all of this information, you should be able to say a few things about each one of these compounds if you are given one of these. Right? So if I am given sodium hydroxide, and CH4, so NaOH and CH4, immediately you should be able to note that this compound is an ionic compound. How do I know it's an ionic compound? Well, it contains a metal, which is a sodium, and it contains nonmetals. By definition, this is going to be an ionic compound. I will know that CH4 is a covalent compound because it contains only nonmetals. There are no metals in there, so it's going to be a covalent compound. Now, when looking at NaOH, you should be able to interpret these chemical formulas. What I mean by that is you should be able to know that NaOH is made up of ions. One of those is an Na plus ion, and the other one is this polyatomic ion here, which is OH minus. Okay, so you have encountered this and you've memorized the charge on this polyatomic ion, or you can deduce it from the chemical formula because you know Na has to have a plus charge because it's a metal in group 1, and therefore what it is bound to must be net neutral, and it must have an overall charge of -1. So you should be able to interpret that when you encounter an ionic compound. All right, let's head over to the covalent compounds. What else should you be able to do? Well, you need to also be able to interpret the chemical formula of such a compound. Right? This is telling you you have 1 carbon and you have 4 hydrogens. So what that means is if we draw the dot symbols for carbon, it has 4 valence electrons because it's in a 4th group of the main group elements. So carbon has 4 valence electrons. Hydrogen is in the 1st group, so it's going to have just 1 valence electron. This is what they are when they are not bonded to each other. That is just the dot symbol by itself. Now, each unpaired electron can bond with another unpaired electron. So this hydrogen can form a bond with that one. This lone electron there can form with that one. This unpaired electron with this one. And this unpaired with that one. And this is how we draw Lewis structures or Lewis dot structures. You may have covered this in your previous course, but because this is going to be such an important and fundamental part of this course, meaning we need to be able to draw Lewis dot structures for simple molecules like this one, and then for very complex molecules. In the next lesson, we are going to focus on how to generate these Lewis dot structures for several different molecules.